Hello, this is the next video in a playlist that I'm calling Mean Variance Moments Mode of Distributions. And we're going to look, in this video, we're going to look at moments of an inverse Burr distribution. And this is it. This is the density of an inverse Burr distribution. It has two parameters, C and K. And so this is x raised to the minus C plus 1. This is x to the minus C. And this exponent is minus K plus 1. All the parameters and the variable have to be positive. And we derived this density in a video that I call Moments of a Burr Distribution. It's actually the video just prior to this in the playlist Mean Variance Moments Mode of Distributions. And essentially what it is, if y is a Burr distribution, then x, which is equal to 1 over y, is an inverse Burr distribution, or a type 3 Burr distribution. So first, let's see if it's a PDF. Let's integrate this density over its domain, 0 to infinity, and see what we get. So let's let y equal 1 over x, and then dy is minus dx over x squared. We plug that in here, and notice when infinity, this goes to 0. Plug in 0, this goes to infinity. But that minus there can be used to switch these limits of integration. And then that is a Burr distribution. And we proved that it integrates to 1 in this video. So it is a density. Now let's find the rth moment. And this can be used for, the mean, the second moment, the third, etc. So this is a very general result. The rth moment is expected value of x to the r, and this x to the r is added into this. So the minus c minus 1 is what this is, and then the rest of it is just the inverse Burr distribution. So let's let y equal 1 over x, and then dy is minus dx over x squared. So then we get, so then this transforms to this. So ck, so that's 1 over y. This is 1 over y right there. We have an extra, if you multiply this up, anyway, so that's the differential right here. So then you start combining things, and we get to this. Right, so if this is into the y, then you bring it up, then all those change. And then don't forget about this extra y that comes in there, and we're left with this. So let's let u equal y to the c, 1 plus y to the c. And then the differential is this. And you can back solve for y to the c. And if you add 1 to both sides, then you get this. You can solve for y here, just take both sides raised to the 1 over c, and then plug everything in here, and you get this expression, right? So the 1 plus y to the c you put here, and then y is this, and that's y, and then don't forget about that r. This can be simplified. I'm a little bit confused there, so I'm back on track. So then this can be simplified. So all these are plugged in here, and we get this. Then we can, invert and multiply, take this up, and solve it to be this. Now, this k is a constant come out front. Then u, 1 minus u, this looks like a beta distribution. So if we had the right constants out front, then this is a beta distribution. We also need some restrictions. This has to be positive, and this has to be positive. Now this is always positive, so this you have to be careful and pay attention. So we're going to multiply by a constant and divide by a constant, and that constant is this, but this is a beta distribution. So the rth moment is k times this beta distribution, where that's 1 minus r over c, k plus r over c. Now once we know the rth moment, we can just put integers in there, whatever number we want. So the first moment is the mean. So that's k times this beta distribution, where we put 1 right here in place of r. Then the variance of x is expected value of x squared, the second moment, minus the first moment squared. So then we get this. Then it's easy to solve for that. The CDF is the cumulative distribution function. We integrate from 0 to some value t. We call that f of t. And this is our density, the inverse Burr distribution. So if we let u equal 1 plus x to the minus c, then du is equal to this. Now notice when we plug in t, we get this, 1 plus t raised to the minus c. When we plug in 0, this blows up to infinity. And that's why this is an infinity. So plug in all this and we get this right here. Then this constant come out front, and then we add 1 to the exponent, divide by it, and then that's the k's cancel, the minus k's cancel, and we're left with this. Now plug in this for u, minus plug in this for u, right? And then infinity goes in here, that's 0, so we're just left with this. And this is the CDF of an inverse Burr distribution. Alright, well that's all I have for this video. Hopefully you enjoyed that. I sure did. Please like the video and subscribe so you don't miss the next one. Thanks, bye.